Hello everyone. Good day to all. I'm Midshipman Gaurav Dahlan, and I'm undergoing the BTech program in the Cochin University of Science and Technology. That is BTech in the Naval Architecture and Shipbuilding. I've got my co-author along with me, so he'll be introducing himself.
Hello, good afternoon, everyone. I'm Cadet Pranav Somshekhar. I'm also currently undergoing the BTech Naval Architecture and Shipbuilding course from QSAT. I'm currently in my fourth semester.
So basically, both of us are here just to introduce you about the maritime industry, how the ships are being made. You would have seen the ships in some of the movies, or some of you must have seen it in real life also. But no one is aware of the real story behind it, how it's made, how what kind of materials are being used. So get Pranav will be taking some of the next slides and will be informing you about it, how it has been made.
So, firstly, we'll start off with an introduction to the maritime industry. Right from the time when man realized that logs of wood can float on sea, the maritime industry has gone on ocean change. So, maritime is anything that is connected to the sea or waterways throughout the world. And this is one industry which has had a large impact on our daily lives. Now, shipping is one of the major forms of transportation from times immemorial, as well as essential for communication and link between coastal cities, countries, and continents. Right from olden times till now, even today, 90% of world trade is actually carried out by the international shipping industry. So, now what is ship production? The construction of ships and other floating vessels is termed as ship production. Now, shipbuilding, when we come to shipbuilding in the modern world, shipbuilding is an industry which started long back and has undergone a lot of changes through the time. Earlier, we used to use materials like wood, and now we have turned to materials like steel, alloy, etc. Shipyards and dockyards are mainly places where these ships are built. They usually exist at major ports or seasides along tidal rivers with easy access to the sea. They include mechanisms to manufacture vessels, place them, or lift them out of water, or drain water around them for access. One of the most significant shipbuilding companies around the world from Asia are all based in Asia. Four of the top five being in South Korea and rest in China and Japan. India is also not lagging far behind with a lot of shipbuilding shipyards like Cochin Shipyard Limited, Madgaon Shipyard, and Garden Reach Shipbuilding Company. They're all leading the way in indigenous shipbuilding in India. Now, coming to the types of ships. There are a lot of ships that we use currently for world trade. One of the basic ones are container ships. Now, container ships, as the name suggests, are specifically used to carry huge amounts of cargo. Now, the way it is carried depends on the type of ship which is used. Now, in container ships, we transport cargo using various containers, and that is why we call container ship. Now, I'll show you a model of the container ship. Now, as you can see here, we see various boxes. These boxes are basically containers in which cargo is transported between various ports, cities, countries, etc. Then we have bulk carriers. Bulk carriers are the kind of ships which transport cargo in bulk quantities. Now, the main difference between bulk carriers and cargo ships is that cargo containers use small containers, while these have huge silos or huge areas where things like dry cargo or bulk quantity can be transported. Now, they do not have any specific packaging and generally contain items like food grains, ores, coals, and even cement. Now, I'll show you a model of bulk carrier. This has been made specifically in our department. Now, coming to tanker ships. Tanker ships are specialized vessels which carry large amount of liquid cargo. They are also further divided on kinds of cargo they carry. Now, this is an example of an LNG carrier which has been built in our department.
Let me add something in this. LNG carries liquefied nitrogen gas. So basically, if we want to carry gas from one place to another place, it is the best way to carry a large amount of gas from one place to another. It has this four structure which you can see. It is nothing but the tankers in that particular vessel. So we have placed the tankers, and in that particular tank, you can call it as cylinders also. It is a huge, massive cylinders. In that you can put on your liquefied nitrogen gas, and you can carry it from one place to another place. So shipping is the easiest way to carry out the large amount of things, large amount of cargo, large amount of gases, large amount of liquid from one place to another place. I must agree that it will not cruise upon more than the 30 knot or something, but the speed is less, but you are carrying a large amount with you, which is more economical.
Then coming on to roll-on, roll-off ship, these are also another kind of transportation vessels which are used for transporting vehicles, cars, and other kind of four wheelers, two wheelers, etc.
Roll on roll off is basically what you can do is if from one jetty to another jetty, if you want to take cars or something, you will just roll on the cars inside the ship, and you take the ship on the other side and you roll off. So the amount of petrol which is being used to drive a car from one place to another place will be reduced, makes it more economical and environmental friendly. This is one of the model which is being made, that is a Roro vessel.
Then passenger ships. These are one which I believe that all of you would be familiar with. Cruise liners, vessels around the world. They are mainly used for transportation of passengers. Ferries are used for transporting passengers and vehicles for short distances routes, whereas cruise ships are mainly used for recreational activities. Cruise ships are luxurious floating hotels with state-of-the-art facilities. You would have come across a lot of cruise companies like Carnival which use these vessels, which are generally easy to spot due to their large size.
So there's lots of scope in the construction of passenger ships. And, however, the size of the passenger ships it varies. Currently, I'm designing a passenger. Currently, I'm designing a passenger ship, which is going to carry 75 passenger in it, and it is going to be operated in the Kerala, and it is cruising by the solar power and the wind power both. So this kind of concept is not at all existing in India, but we are trying to make it if it is possible. What I have done is I have put the solar panels on the rooftop of the vessel, and the mast has been put on the top of the solar panels on the top of the solar roof. So when there is some cloudy season or something, that time the wind assistance can be taken. Otherwise there is in unfavorable wind and there is no solar power also. We have got these good set of battery parts that can be used for it. So it's a good concept.
Now, coming to offshore vessels mainly help in jobs like oil exploration, construction, and sea. There are a lot of kinds of offshore vessels like supply ships, pipe layers, drill rigs, drill ships, production platforms, and accommodation barges.
So basically, call it OPVs. This photograph which you can see, this is a fishing trawler vessel. This white mast which you can see is just for pulling the net. So you would have encountered some fisherman or someone catching the fishes. But if you want to go more deeper into the sea, more towards the sea, it will not be possible for a fisherman to catch the fishes of a bigger size or more amount of fishes. We need to go towards the sea. For that kind of operations, these kind of vessels are being used. These vessels, what they'll do is they'll put the net over this part. I hope you can see my cursor. They'll put the net over this, and they have got a crane arrangement. This is basically the lever arrangement, and they will catch up all the fishes and they will put it on board. So these are fishing vessels.
Now, coming to naval vessels and warship. Vessels and ships are used by navies around the world since long time for maritime security and surveillance. They are capable of carrying various warheads which are used for defense activities. They divide into several types based on size, the weapons they carry, the amount of people that personnel that travel in them. They are divided into destroyers, frigates, cruisers, aircraft carriers, oil tankers, and survey vessels.
So basically, I will introduce you with this kind of vessels. When we talk about the naval vessel, it is totally different. There is no luxury in the naval vessels. And first is given the destroyer. It is quite evident from the name itself. Destroy is just to destroy. We want to destroy the ship which is encountering towards us. Frigates has got a good set of the armaments on the main deck of the vessel. Cruisers basically there is less number of cruisers for navy, but yes, small size of cruisers are available. Aircraft carrier, as you all of you must be aware that India is making an indigenous aircraft carrier, that is IAC project. It is where we are hoping very soon it will be commissioned in the navy. So that aircraft carrier, first time India is making an aircraft carrier which supports the Make in India concept of RPM. When we talk about aircraft carrier, we can carry around 30 to 40 of the aircraft, that is helicopter or aircraft, on board a ship, on top of the ship. And whenever there is some situation of war or something, it can be used very well. And it is not like the aircrafts are being carried only on the top of the deck. It is not like that. We can store it in, we have got the good hangars, good space of hangars. And there itself in when we talk about oil tankers, we have got ISS Jyoti. Survey vessels, there are lots of survey vessels which protects our maritime borders in daytime, nighttime, 24 by 7. So these are the models of frigate. There is a submarine which you can see. and there's one whole craft. Per se, whole craft are not being existing in Indian Navy, but yes, it can be used for military purposes. And the last one which you can see is the aircraft carrier.
So now, why do we make models? So these are the few basic factors due to which we build ship models. One is the 3D outlook, so that we understand, because it is not possible to design a ship and then to build the whole thing and rectify errors in it. So we build a small 3D model of it, so we understand how the ship looks after construction. This also helps describe the aesthetics of the ship without actually completing. There are also other factors which which are used why we build models. One of them is stability. Now, when we have a particular design, we cannot check how stable it is just by looking at the design. So we build a model and we put it in a small tank to conduct various tests on it, which determine the stability, resistance, which is the motion of a ship when it is flowing in water, sea keeping, which helps determine the ability of a ship to stay afloat in water under various atmospheric conditions. And also we can run several simulations on this model, which helps determine the best possible design which can be used to create a particular ship. So once we have this model, we can determine a lot of parameters from it, from which we make changes in the design and changes in other various other factors, which helps make the best possible design related to a particular parameter. Again, why make model? Because visualizing the behavior, it helps us visualize the behavior of a ship without actually having to build the entire ship, which helps us to make corrections in errors of design and various other small things which can be fatal if we make it into a full ship and then we realize that there is an error or something. So errors and inaccuracies are assessed right from the very beginning and early stages, which helps us take precaution and test at precaution steps to correct these measures at each and every step.
Basically what he's intending is, like, if we have made a big ship, so it is not possible for us to put the ship into the waves. We cannot generate the waves, we cannot directly put it into sea, because it will be very harmful for the life which are being carried on board a ship. So what we are doing is we are just making some models, and we are putting those models into some tanks. We call it towing tanks. So in tanks we keep it, we generate some waves, and we extrapolate the results which we are getting. Per se, if we have got the at the speed of 5 knots, we have got some resistance of 1.2 kilonewton. This kind of resistance is being observed. So that can be multiplied with that factor, form factor, and we can just estimate. We can get a approx estimation that when we are going to put a ship in this kind of situation, these are results will be there. So accordingly, the structural design of the ship can be done. It can be made more stronger, and whatever maneuvering requirements, whatever stability requirements, that can be met using this kind of processes. So we'll be showing these processes how it is done.
So now, choosing the correct hull form is one of the biggest factors. So that is one of the major reasons why we conduct these tests, because the hull is the most exposed part of the ship. It is basically the outermost part of the ship. It is generally waterproof, and in most cases it's delicate. It dictates the various components of the ship's motion. So in order to optimize the ship's hull form, we perform such tests using models.
So hull form is nothing, and it is just the bottommost part of the ship. The bottom, the biggest part which you can see, that is the hull of the ship. In this photo, you can see, and there is a screw. This is a propeller which is being, you can call it as a fan, which provides a thrust power to the ship. The force is being generated, and the ship moves ahead. So there are different kind of hull form which are being used in this ship. You can see this is a transom hull, and it is kind of V-shaped. So they are catamaran, twin hull, two hulls, trimaran, pentamaran, five hulls. So there are various kind of hull form which are existing. Ship to ship, it depends which kind of hull form has to be taken.
Then sea keeping, as I had explained earlier, is the ability, it's also known as the sea worthiness, is the ability of a ship to stay afloat under various conditions of sea and atmosphere. So it is a yardstick to estimate the vessel's behavioral efficacy during at sea or underway its voyage. When we talk of efficacy, it pinpoints specifically to the motions and dynamics of vessel in water. So what we do is when we make these models, we put them into the tank and we recreate those models on a much smaller scale, which helps us determine the how the ship would behave if put in such a situation in real life. Then coming to resistance of motion, every ship which flows through a particular fluid body like a channel or a river or sea always faces some amount of resistance. So the motion of the ship requires energy to overcome this resistance. That is the forces working against this moment. The knowledge of resistance of ship is one of the most basic things that you need while designing a ship. Total resistance in calm water can be divided into three main components, that is frictional resistance, residual resistance, and air resistance. So building of ship models helps us determine these resistance, which help us make the design such that it can help reduce the amount of resistance.
Basically, when you're designing a car or something, there will be aerodynamics which has been followed. This is because we are making our car like a streamlined body in front of it. So same concept is being followed in a ship. The bow part, which is front part of the ship, it is structured in a V shape so that the wave making phenomenon, or let's say wave breaking phenomenon, both of the phenomenon, it must withstand with it. And when it is cruising at a good speed, or at minimum speeds also, this resistance is the biggest factor for it.
So now, what kind of materials do we use to actually make these models? So one of the most basic materials that we use to build these models is multi-wood. Yeah. So, as you know, wood is one of the most basic materials which was used earlier onwards to build ships. So, wood is the most versatile of all model building materials. Different types of woods have different properties. Not only the superficial, such as color and texture, but also when it comes to stability, stiffness, and strength. So, there are also some lesser obvious properties that come into play, such as prone to checking the ability to bend without cracking. Multi-wood is generally white in appearance and it is easy to bend and form into models. It is one of the most basic tools which is used in ship model making. Then we use modeling wax and paraffin. Modeling wax is simply a formulation of wax that is soft and easy to be modeled by hand. It is usually supplied in solid block form, and the wax readily softens with heat action being worked between the fingers. Most modeling waxes are just a few common ingredients such as beeswax, paraffin wax, or microstyrene. We also use fiberglass nowadays in ship model making. Fiberglass is the most common form of strand mat or woven fabric. It can be used in a combination with resin or outside a wooden strip planked hull to seal and stiffen it. A hull can also be made entirely out of fiberglass. It requires a positive pattern be made first.
So fiberglass, this is something which is being used for the models as well as the ship. The concept design which I was talking about, like the catamaran ship for wind and solar ferry, which I was talking about for Kerala Indian waterways, it is being designed with the fiberglass only. But only drawback of using the fiberglass is we can only use it for the small length of vessels. Means it can only be used for vessels per se lesser than the 25 meter of length. Above that you can't use. But what you do is the basic process of making fiberglass is you just make a mold out of it, and you start putting the uh, fiberglass on inside. Either it can be inside, either it can be outside of that mold, and you start making the hull. After it dries up, you put the more layers on top of the already existing layers, and it is in accordance with the kind of vessels you are making. And then it can be one of the best benefit of the using FRP. You need not to paint it. The other ships which are be made of steel ships or aluminum, whatever, you need to paint it regularly just to avoid the corrosion which is happening on the surface of the metal which is used. For FRP, you need not to do that.
Another important tool in making such things that we use various workshop tools which are used in model making like lathes, sander, drilling machines, saws, clamps, and planners. So now we'd be showing you how we actually use these tools to build real life ship models. So there are a couple of videos that we'd like to show you that we have taken from our own department, which help illustrate how we actually use these tools in order to make real-time ship models.
Are you able to see the video?
Chain motorized machine. So the chain motorized machine, as you can see, this is on button in off position and this will be on position. This is the way you get oil for the machine. These are instructions. When you pull this handle down, the machine will start, and when you pull it up back, it will stop. This is the chain of the handle. The workpiece will go here. You can adjust the location of the workpiece by using instruments like this. This is like a adjust and clamp the workpiece to the machine. This is used to move the edge left and right and just forward and back. Now, you have the workpiece and you put it onto the machine. Now it nicely clamped. Put it down, the machine started. Now it is. Now I'll show you how to take it. Now I'll remove the workpiece. And as you can see, there's a very neat bow. That is our chain motorizer machine. Hello everyone, I'm Pranav. And here let's demonstrate the jigsaw machine. Now you can see, jigsaw machine is used to cut wood into various shapes, which is specifically used for making drawings. This has a very thin blade like this, which can be used for cutting the wood. This goes here. This goes up and down at very high speed, which can be used for cutting and making instruments like this. This is only made during the jigsaw machine. Now, we'll show you a demonstration of how we're going to make anything like this. So here, I have a wooden workpiece. On this, I have marked the circle. Now, I'll show you how to cut this circle using the jigsaw machine.
रुक जाओ.
This is a power button. And turn to this side, now the machine is on. jigsaw machine. But as you can see, the surfaces are not smooth. So we have a couple of machines that we can use to make it smooth. One is a sanding machine. Sanding machine can be used to smoothen wooden surfaces, especially the edges. But as you can see, it's a very small small workpiece. So we have two other options. One is a grinding machine. A grinding machine is used mainly for metal surfaces. Today I'm using a sander. As you can see, this is a sander. I'm connected to this point and I switch it on. As you can see, now the wooden edges are smooth. Using this machine, you can make edges of workpieces. Thank you. So now we have the wooden wood part that we have cut using the jigsaw machine. Now, as you can see, this workpiece is very rough. So it is moved to the surface. First, I've adjusted this workpiece on a belt joint. Now, we will use an equipment called the portable and planer. So, a few things to keep in mind while using this equipment. The first of all, it always needs plain and plain oil. Ensure this both edges and between the surfaces configured. Now, while you're doing it, please ensure that this handle does not go down or up. Always create this comfortable line. Now, this is now. Now, the surface is completely plain. Also, a few things to keep in mind after using this device, please always keep it at the side because the brake will spin it. Length of the brake can be adjusted according to depth if you want it to be smooth. Thank you. Hello everyone. Now we have matching dust collector. As you use a lot of machines today, we have created a lot of dust. To clean out the dust, use the matching dust collector. Now, how does this work? This is power. You can keep it on for a minute. There is a motor behind which generates the heat, which runs the wheel, which creates such a force required to pull due to the power. Now, I'm turning it on.
So it was a overview how we are using this kind of machines and all to just make the models, and after that you saw that the housekeeping also done to keep the shop in the same state which we were using. So there are lots of applications of the mechanical workshops which are already there in a department. That is, first is gears. Gear is the very basic component of a machinery which is being used in the lifts, elevator, pumps. power plants. Davits are something which are being used to lift up the small boats which are on board the vessels. Because in the case of emergency, we will have to evacuate the vessel. We'll have to go out of the vessel in the emergency case. So we keep the small boats on a big ship as a standby boats. Boat lowering mechanism, that is which is relatable to the davits. The boats are connected to the davits. They are being suspended on the davits, and it is being lowered into the seawater, then engine. So this gear, it is used everywhere. It is the very basic component. Coupler is used for the shafting. Shafting is used in the propeller of the vessel. Propeller is something which I saw, which I have shown you in the hull form slide. In that, it was shown there is a propeller at the aft part, the behind part of the ship. So in that, when we are putting lots of the shaft components for the prime mover of the vessel, that time we are using the couplers. And conveyor belts are basically to transform the power from one component to other component in the engine. Pipe system, there are lots of pipe system on board a ship. That is Bill's blast system. Then we have got the sewage system, then filtration plantation unit. Lots of ship. Let me tell you, it is kind of a small existing city. So there are lots of components. Then engine room, I already explained it. Power transfer conveyors, propeller system. Piston is being used in the engine. However, it is not directly relatable to the naval architecture per se, but it is primarily used in the ship engines. It is something related to the mechanical shop. Connecting rod, again, it is a part of the engine. So these all components are being made by the students of the Department of Technology. Then flanges for the coupling arrangements, pipe joints. Wise is used for handling the material which you are using, handling the work which you are doing. You would have observed it in the wooden shop, which some video which I showed you. In that video, he is putting the plank into the vise, then he is using it. It is very basic thing of a workshop. So basically, we have showed you the very basic things of the ship industry. However, it is a vast industry. There's lots more to be explained, but in due to the shortage of time, we just gave you the overview about it, how the ship industry is. So now we are open to the questions, if you have some questions.
Hi, sir. So, what do you think will be the next big development in the model making space?
See, as I already explained you that the uh, as of now we are going for the concept of the Make in India, that is making the first Indian aircraft of the ship aircraft of the India. So we can hope for the second aircraft. That would be the future.
Are there any other fields that model making can make a big difference in?
Sorry, can you say again, Anushri?
Yeah, so are there any other fields that you see model making help make a difference in? Not just ship,
Any industry
not just
other
ship
than
design.
this? Other than this? Okay, okay.
Yeah.
See, other than this, we have automation industry, mainly the vehicle industries. In the automobile industry, they are using it for the damage controllability of the cars. Just they'll make a model of the car, and then they will hit it towards for a particular force. They will test it, and when we are designing airbags or something for the cars, it has been used. So for ship, there is lots of hydrodynamics and all which we are using, but for cars, it is just the accidental safety. So it can be used in automation industry.
What advice do you have for those interested in the field of modeling right now?
See, there is lot of scope for it. And when we talk about the naval architecture, there are only three institutions in the India. So these are large scope. If I talk about India, there is very less maritime borders in the India, because it is only in the peninsular area of the India. But if you go abroad, when you go in the countries where they have got the entire periphery, which is surrounded by the waters, surrounded by the sea, so the scope increases. So they can go abroad, but going abroad does not means that they will forget the country per se. They should always pay back to their country. So if they are going there, they should bring back some technologies to India and should be implemented in India itself.
Thank you. That was a
Thank you.
very enlightening and enthralling presentation. We are happy to have you here for another showcase of the Pragyan 22 exhibition series powered by Salesforce.
Thank you.
Uh, we take we take this opportunity to thank Higher Education Review, our higher education partner, Blogada, our blog outreach partner, JAMP, College Search, Y Engineering, and Engineering Facts, our online media.
Thank you for tuning in. With more exciting exhibits and shows coming your way, we hope you enjoy day 2 of Pragyan 22. Thank you.